My name is Tonae Patterson, and today I will be showing you how to use integration by parts. Integration by parts allows you to rewrite your given integral using a new integral so that your given will be easier to integrate once you plug it all into this formula. So first we want to find our u and our dv. Our u variable, you want that to be whichever of your two factors is the most simple to differentiate, and we see that 9x would be more simple because after differentiating it, we will just get 9, so it's a constant. So we will choose 9x to be our u, and e to the x dx will be our dv. Next, we want to find our du and our v variables. We find our du variable by differentiating u. So we know that after differentiating u, we will get 9 dx. And after, to find our v variable, we will just integrate dv, and by rules of integration, it just stays e to the x. It doesn't really change. So now we will plug it all back into this formula. So we started off with u times dv, which is our given, 9x e to the x dx. And now we want to plug in our u and v, which we have here, u times v, 9x e to the x, minus the integral of v times du, which is e to the x times 9d to the x. And we always want to put the 9 in front as our leading coefficient. So when we write this as 9 e to the x dx. So now we see that we have to find the integral of 9e to the dx, and by rules of integration we know that e to the x will stay e to the x, and we'll just leave the 9 in front as well. So this 9e to the x dx integrated will simply be 9e to the x. So now we will bring this down, our uv, since we've solved the integral of v times du, and we will say 9x e to the x minus, we've already solved our integral, and lastly we want to add plus c. You really don't want to forget the constant because this is an indefinite integral, so it has no limit, so you want to add the c. So this here is our answer. So basically what we've done using integration by parts is broken this down or rewritten it so that it is easier to integrate, which is using this or